Welcome to the geography lesson. Today we're going to discuss mid-latitude cyclones. But before I want to continue, let's just quickly look back to the previous lesson when we discussed synoptic charts, weather station models, and low and high pressure systems. As well that we discussed global air circulation. Now, to move forward, we just need to pick up a couple of things from the previous lesson. We looked at global air circulation. Now, as you can remember, the global air circulation with the different pressure belts, there's the equatorial region, the 30 degree, 60 degree, and 90 degree pressure belt. And we've established that that's a high pressure belt, a low pressure belt, high pressure belt, and a low pressure belt. Then we looked at synoptic charts as well. Very importantly, with today's topic, mid-latitude cyclones, you need to be able to identify and describe this type of low pressure systems on a synoptic chart. And we're going to discuss them in detail so that you can understand, and when you get a synoptic chart during the grade 12 exam paper, that you will be able to identify it and interpret it. Now just quickly look at the name, mid-latitude cyclones. Basically, we can decipher it and kind of explains exactly what it is. Now, if we look at mid-latitudes, there is 0 degree, that's the equator, and that's 90 degree. So it tells us, the name tells us is mid-latitude. So mid-latitude between 90 and 0 degrees is probably 45 degrees. It's somewhere in this region over here. So just by the name, we already know this is where this system originates. And then, like in our previous lesson, we looked at low pressure and high pressure systems. Now, with secondary air circulation, a low pressure system we refer to as cyclones, and a high pressure system is known as an anti-cyclone. Now, to revise once again, when we look at low pressure systems, what did we say? It is rising air. Why does the air rise? Because of warm conditions, like at the equatorial regions, or because it's forced to rise, like the subpolar low pressure belt. It's warm conditions, that's the reason why it rises at the equatorial low pressure belt, and it's been forced to rise because cold polar air and warm tropical air meets and forces the warm air to rise. And we know it's rising air, and we discussed high pressure systems, and we established that it's sinking air. Why? Because of cold conditions. Now, as the name indicates, what do we know? Mid-latitude cyclones, formation takes place in the mid-latitudes, and cyclones is low pressure systems. And what do we know? It's air that rises because of warm conditions or because it's being forced to rise. Very importantly, when we look at low pressure systems, cyclones in the southern hemisphere, it's a clockwise circulation of air. And a high pressure system, an anticyclone, is anti-clockwise circulation of air. Now let's just quickly look at this name, mid-latitude cyclones. Now first of all, we need to look where does the formation take place. And over here is the area of formation. It forms between the boundary of two prevailing wind belts, in this case between the free tricellular air movement between the polar and the feral cell. Now this where the cold easterlies are and the subtropical westerlies are. And this is the area where they are formed. Now, this is a cross-sectional point of view. Just to explain this diagram, this is basically global air circulation from a cross-sectional point of view. Now, as you can see, what we have over here, we have the equatorial regions, air rising. Why does this air rise over there? Because of extremely warm conditions. Eventually, what does the air do in the upper atmosphere? It diverges. and eventually it will cool and it sinks down to the bottom of the surface. Now obviously, as you can see, a void is being left over here, divergence are taking place over here at the subtropical high pressure area, but there's convergence taking place. Now in the last lesson we've learned about the ITCZ, intertropical conversion zone. What happens over there? There's tropical regions, there's a convergence of air. This air moves towards one another, and it rises. And as you can see in the background over here, you can see cloud formations. Why? Because the air cools, it condenses clouds, and it leads to rain. Okay, now let's just quickly move to the polar regions over here. We've established, if we look at the polar regions, extremely cold temperatures, so the air sinks. If you look at the polar regions, usually covered with ice and snow, very cold conditions. So we experience the polar high pressure belt over there. Now what do we know? The air moves, as you can see, it diverges. That's very cold air. And on this side over here is warm air from the subtropical high pressure belt over here. And where this air meets, we experience a low pressure zone. This air rises. Why does it rise? Because there's cold air from this side, warm air from this side. What does the cold air do with the warm air? It forces the warm air to rise. Now the area of formation for mid-latitude cyclones is situated between the polar cell and the feral cell. And as you can see, the air over here is cold air coming from the polar region. The air coming from here is warm air coming from the subtropical high pressure belt. Now very importantly, I want to introduce you to the term polar front, this black line over here. Now the first question I want to ask yourself, what is a front? A front, if this is my front, a front divides two masses of air. So basically what this polar front do over here, it divides warm air from cold air. And this is where the formation of mid-latitude cyclones, and this is where it takes place. Because there's a polar front, and then one side there's cold polar air coming from the one side and warm air coming from the subtropical high pressure belt from the other side. So the front separates the two masses of air, and it happens between the polar cell and feral cell. Now, from a global air circulation point of view, where does it take place? If you look here, there's a 50 degree, 0 degree, 50 degree, 60 degree. And there's a 90 degree. So basically what happens over here is cold air coming from that side, it's warm air coming from that side. And then we've got the polar front over there. It separates that warm air from there and the cold air coming from the polar regions. And it forms between the polar and feral cell. Now, if you look at the next diagram, this is the mid-latitudes. Let's fill this in. 0 degrees, 50 degrees, 60 degrees, and obviously 90 degrees. So as you can see, the formation, where does it take place? Now, very importantly, the system moves from west to east. As you can see, look at the arrows. Why does it move from west to east? Let's go back to our previous diagram. In the previous lesson, we looked at the movement of air. Air moves from a high pressure to a low pressure. And we established at the 90 degree, there's a high pressure, there's a low pressure. There's a high pressure, and there's a low pressure, because of warm conditions. Now, because of deflection of the wind, known as Coriolis force, air deflects to the left. Now, this system, like the name indicates, mid-latitudes, originate in this area over here. Just use a different color pen quickly. And obviously, the air moves from this high pressure to this low pressure where it's deflected, and it moves in the westerly wind belt. Now, as you can see on the diagram over here, the system moves from west all the way to east. So the name is basically a given away. Mid-latitudes, between 40 and 60 degrees latitude, north and south of the equator. And obviously, very importantly, we call it a cyclone because it's a low pressure, it's rising air. Okay. Now, if you look at the characteristics of a mid-latitude cyclone, it's an extensive area of low pressure surrounded by high pressure systems. Now, on the synoptic chart, they appear ovally shaped. Now, down here I've got a synoptic chart, but let's just quickly fill in the degrees of latitude over here as well. So, this high pressure belt is a subtropical high pressure belt that you see over here. And then over here, we have the 60-degree subpolar low pressure belt. And let's just extend this like over here. There's the 90-degree polar high pressure belt. Now, as you can see, the isobars are oval in shape. Very importantly, like I've mentioned just before, this mid-latitude cyclones is surrounded by high pressure systems. The subpolar high pressure system, the subtropical high pressure system. As you can see, the isobars are ovally shaped, situated over there. Now, very importantly, when we look at the synoptic charts, the lines joining places is known as isobars. Now, when the isobars are far from one another, now keep in mind, air moves from a high pressure to a low pressure. It's the same as in map work. When the contour lines are far from each other, it's usually a gentle slope. Now, in this case, when the isobars are far from one another, we can say it's gentle winds. Now, if the isobars are very close to one another, and the air moves from the high pressure to the low pressure, we can say we experience very strong winds. Now, in our previous slides, we have already established. I just want you to have a look at this synoptic chart over there. Over there is our mid-latitude cyclone. Look at the movement of the system. From west to east, because it moves in the westerly wind belt. And as you can see, it's a low pressure system. And what's the circulation of air in this low pressure system? Clockwise circulation. Now, that's the characteristics that we already discussed prior to this synoptic chart. As you can see, the pressure gradient is relatively gentle, meaning that the isobars will be far from one another. So what do we know? It's gentle winds, not very strong winds. Okay. And as I discussed and showed you on the synoptic chart just below, the system moves from west to east in the westerly wind belt. We're going to take a short break, and afterwards we will continue again with mid-latitude cyclones.